Tectonic. Tectonic earthquakes are the most common type, occurring when massive sections of the Earth's crust shift along fault lines. This sudden movement releases enormous amounts of energy, causing the ground to shake violently. The magnitude of these quakes can vary widely, typically ranging from 5.0 to as high as 9.5 on the Richter scale, making them capable of devastating entire regions. One of the most powerful examples was the 2004 Indian Ocean earthquake near Aceh, Indonesia, with a magnitude of 9.1. It triggered a massive tsunami that claimed over 200,000 lives across multiple countries. Tectonic earthquakes can destroy infrastructure, collapse buildings, and in underwater cases displace huge amounts of water. They are responsible for most of the world's deadliest seismic events in recorded history. Because they are linked to plate boundaries, they often occur repeatedly in the same region. Volcanic. Volcanic earthquakes happen due to the movement of magma and gas beneath active volcanoes. As pressure builds, the surrounding rock fractures, causing small to moderate quakes that can signal an impending eruption. These earthquakes are usually less powerful than tectonic ones, often ranging between magnitude 2.0 and 6.0. However, they can still be extremely dangerous when combined with volcanic activity. A famous case is the 1980 Mount St. Helens eruption in the United States, where hundreds of volcanic quakes preceded the explosive event. The impacts can include pyroclastic flows, lava streams, and massive ash clouds affecting nearby towns. Volcanic earthquakes also contribute to landslides and ground deformation. Monitoring them is essential for early warning systems around active volcanoes. While their damage range is usually local, the combination of earthquake and eruption can be catastrophic. Collapse. Collapse earthquakes occur when underground voids such as caves, mines, or salt deposits suddenly give way. This type of quake is usually highly localized, affecting only the immediate area around the collapse. Their magnitudes are typically small, ranging from 2.0 to 5.0, but they can still cause significant damage in populated zones. A well-known example is the 1995 collapse earthquake in Solikamsk, Russia, which created a massive sinkhole swallowing part of a city block. The impacts often include ground subsidence, destruction of buildings, and loss of infrastructure. Collapse earthquakes are often linked to human mining activities, but they can also occur naturally in karst landscapes. Although they lack the wide-reaching power of tectonic events, their suddenness makes them extremely dangerous for people nearby. Early detection is difficult because they often strike without warning. Preventive monitoring in mining and cave-rich areas can reduce their risks. Impact. Impact earthquakes are among the rarest but most destructive types, caused by large meteors or asteroids striking the Earth's surface. When such an object collides with the planet, the energy released can equal or exceed the largest tectonic quakes. Magnitudes can surpass 9.0, depending on the object's size and speed. The Chicxulub impact 66 million years ago is one of the most famous examples, believed to have led to the extinction of the dinosaurs. The shock waves from impact quakes can flatten vast areas, ignite wildfires, and even alter global climate. Although such events are rare in human history, smaller impacts can still trigger localized seismic activity. The main danger comes from their unpredictability and potential for mass destruction. Modern space monitoring aims to detect and divert near-Earth objects before a catastrophic impact occurs. Induced. Induced earthquakes are man-made, triggered by activities like mining, fracking, reservoir filling, or underground nuclear tests. When humans alter underground pressure, it can cause faults to slip, resulting in seismic activity. These quakes are usually moderate, ranging between 3.0 and 6.0 in magnitude, but in some cases they have caused significant damage. The 2011 Oklahoma earthquake in the United States, linked to wastewater injection, reached a magnitude of 5.7 and damaged hundreds of buildings. Induced earthquakes raise questions about the safety of industrial practices and their long-term effects on the environment. While they are less powerful than most tectonic events, their increasing frequency near drilling sites has drawn global attention. They demonstrate that human activity can influence geological processes. Pressure. Pressure earthquakes occur when underground fluids or magma suddenly release built-up stress. This sudden movement of material inside the Earth cracks the surrounding rock and creates tremors. Their magnitudes typically range from 3.0 to 6.5, making them moderate but still capable of damage. A well-known example is the series of pressure-related quakes near Iceland's geothermal fields, which are closely monitored due to their connection with volcanic activity. The impacts include surface cracks, minor ground uplift, and in some cases triggering small eruptions. Pressure earthquakes highlight the dynamic nature of the Earth's interior and its constant movement. They often act as a warning for potential volcanic or hydrothermal activity. Monitoring them is key for energy projects in geothermal regions. Understanding pressure quakes also provides insights into how fluids move beneath the crust. Tsunami. Tsunami earthquakes are underwater seismic events that displace massive amounts of water, creating giant waves that can travel across oceans. These quakes usually require a magnitude above 7.0 to generate significant tsunamis. One of the most devastating examples is the 2011 Tohoku earthquake in Japan, which reached magnitude 9.1 and unleashed waves over 40 meters high. The impacts include catastrophic flooding, destruction of coastal cities, and large-scale loss of life. Tsunami earthquakes are particularly dangerous because the shaking on land may feel mild while the ocean displacement is massive. This can delay evacuations and increase casualties. They demonstrate the strong link between tectonic activity and ocean dynamics. Coastal regions worldwide rely on tsunami warning systems to reduce their risks. Understanding these earthquakes is vital for protecting millions living near the sea.